In this day 2 of graphing rational functions, we're going to look at the other form and see how it's different. So if your rational function is of the form p of x over q of x, some of our steps will look different. So we're going to make sure both the numerator and denominator are in standard form. For the horizontal asymptote, if the numerator's degree is less than that of the denominator, then the horizontal asymptote is y is 0. If the degrees are equal, then it's going to be the quotient of the leading coefficients. So that means if it was like 3x plus 5 over x plus 2, we would take the 3 over the 1 and make it 3. If the numerator's degree is more than the denominator, there is no horizontal asymptote. There's something called a slant asymptote, which we are not going to worry about, but that would exist instead. We're going to factor the numerator and denominator. The vertical asymptotes, now this is in parentheses here, plural, because it's possible you can have more than one vertical asymptote, are any x values that make the denominator 0, but there's a caveat. If a factor cancels out in the numerator and denominator, there's actually a hole in the graph at that x value. We could plug it back in to find what the y value would be of that hole. But again, we're not going to worry so much about holes, but it is possible that there could just be a little dot within our graph that there's no number that exists there. So for example 1, we're just going to find the asymptotes. So these are even degrees, right? This is to the power of 1, this is to the power of 1. So my horizontal asymptote will be the 5 that's in front over the 1 that's in front, and 5 over 1 is 5. My vertical asymptote is whatever makes the denominator 0, so that would be x is 3. In this one, the degrees are not equal. In fact, the degree of the numerator is less than that of the denominator. So automatically, my horizontal asymptote is going to be y equals 0. Then my vertical asymptote, we need this to be in factored form. So 2x minus 1 doesn't get factored any further, but x squared minus 4, that's a difference of squares, is x plus 2x minus 2, which means I have two different vertical asymptotes, right? Because nothing's canceling out. I don't have an x plus 2 on top. I don't have an x minus 2 on top to cancel out. So we're going to say x equals -2 and x equals +2 are my two vertical asymptotes. For this one, the degree on top is higher than the one on the bottom, so there is no horizontal asymptote. Okay, degree higher, no horizontal asymptote. It would have been x plus 1 and x minus 1 on top and x plus 4 on the bottom. Nothing cancels, right? There's no x plus 4 on the top to cancel out. So just whatever makes the bottom 0, x equals -4. And for one more, we'll do together. So we see that they have even degrees. So my horizontal asymptote will be the 1 over the 2. So y will equal 1/2 for my horizontal asymptote. My vertical asymptote, I'm going to have these in factored form. So the top factored is x minus 4 and x plus 2. The bottom, if I first took out the GCF of 2, I would then have x squared minus 4x minus 12. So that's x minus 6 and x plus 2. So notice here, my x plus 2's, there's one on the top and one on the bottom. So those would cancel out. So technically, there is a hole at x equals -2. It's not an asymptote, there's a hole there. The remaining factor, the x minus 6, that is where I will get my vertical asymptote. So that will be x equals +6. If we wanted to know the exact value of the hole, I could take this -2 and plug it back into this, ignoring those factors, right? Plug it into the simplified form, and it would actually tell me it's at -2, 3/8. But we don't need to know where the hole is. And that's it for the lesson. There's 3 for you to try. You can end it here and then just check to make sure you got them correct in the blank notes that are posted on Google Classroom. And that's our day 2 of graphing rational functions.